So when we're setting up a problem, we need to identify the given unit, the one that we need, and then our plan. For example, how many minutes are in 2.5 hours? So the given is 2.5 hours. The one that we need is minutes, and then we need a plan, how to go from hours to minutes. So we're going to write 2.5 hours, and then we're going to use a conversion factor that places hours in the bottom, minutes on the top, and then multiply 2.5 times 60. Our calculator will give us a number, but then we have to round to two significant figures. So our answer is 150. How many minutes are in 1.6 days? So we're going to go from days to minutes. So here we have different conversions. We need to go from days to hours, and then from hours to minutes. So we set up the problem. We start with the given, which is days, and we're going to go to minutes. We're going to use a conversion factor that go from days to hours, placing days in the bottom so they can cancel out. And then from hours to minutes, placing hours in the bottom so they can cancel out. Again, you do your multiplication and your final answer should have two significant figures. Let's do these problems together. If a ski pole is 3.0 feet, how long is the ski pole in centimeters? So the given is 3.0 feet, and the one that we're going to is centimeter. So since we don't have a conversion factor that goes from feet to centimeter, we look at our equation and we see that we can go from feet to inches and then from inches to centimeter. We're going to place feet here and inches here, and then inches here and centimeters here. 1 inch, 2.54 centimeters, 1 foot, 12 inches. So we do our calculation and we take 3.0 times 12 times 2.54. Our calculator gives us this number, but we know that our answer has to have two sig figs, so we're going to cut it right here, and our answer is going to be 91. Okay, so we'll do the second one. An injured person loses 0.3 pints of blood. How many milliliters is that? So we have the given is 0.3 pints. We're going to go from pints to quarts. So we say 1 quart is 2 pint. And then from quarts to milliliters. 1 quart is 946 milliliters. Now again, all these conversions will be given, all these quantities will be given. You just have to learn how to set up the problem. When we do the math, our answer is 141.9. Our starting had one significant figure. We're going to have, here. It has 3 significant figures, so our answer will be 142 milliliters. And then the last one, if your pace in a treadmill is 60 meters per minute, how many minutes will it take to walk 7,500 feet? So we're going to convert these feet to meters. And the way to do it is feet to inches, and then inches to centimeters, and then meters to centimeters. Right? Then this gives us 2286 centimeters. We're going to convert that now, saying these many centimeters, we're going to convert that now to what was the to minutes. So we're going to use the conversion factor that say that this person walked 65 meters in 1 minute. So this person walked in 1 minute 65 meters. Okay, so in here we had it in centimeters, so we have to convert those 100 centimeters 1 meter, so they can cancel out. The answer to this problem should have two significant figures, so the answer is 35 minutes. The last part of this chapter is about density. Density is mass per unit volume. Usually is in grams per milliliter. Something like this is heavy but it's not dense. Something like this is dense but it's not heavy. So density can be calculated mass over volume. One way to recognize it is like this. This part over here for M, mass, this for V, volume. So the density of the substances is recorded in tables, and they are used like this. You don't have to memorize any of this, but you can, by looking at this, you can see that, for example, ice has a lower density than water. That's why ice float over when you put it in water. For example, oil floats because it's less dense than water, and a coin will sink because it's more dense than water. So if you look at this picture over here, you could tell that the most dense is this one because it's in the bottom. Then we have aluminum. Then we have here we have the water. Here we have the ice, and cork, which is the one that is less dense. So we could do problems like this. How many milliliters of mercury are there in 20.4 grams of mercury? So we can start 20.4 grams, and then we say, given the density, we know that we have to place grams over here, milliliters here. So 1 milliliter is 13.6 grams. The answer is going to be 1.5 milliliters. Or how many grams of milk are there in 0.50 quarts? For something like this, we take 0.5 quarts and we convert that to milliliters because the density is given in milliliters. So is 946 milliliters is 1 quart. So that is 473 milliliters. So we have the volume, we have the density, we need to find the mass. It will be 473 milliliters times 1 milliliter, 1.04 grams, and the answer is 492 grams. Specific gravity is the ratio of the density of a substance and the density of water. So basically it's a comparison with between the density of a substance and the density of water. The density of water is 1 gram per milliliter. So if a liquid sample has a density of 1.23 grams over milliliter, what is the specific gravity? So we're going to compare that to the density of water. The specific gravity will be 1.23.